Okay, so now we're going to practice factoring special patterns. Okay, so the first special pattern we're going to look at is the difference of two perfect squares. So, example 1, 25x squared minus 9. Now, the first thing that you may be noticing is that there is no middle term. We're used to seeing a b, right? So something x would be in the middle. We don't have that here. And if you look at the name of the special pattern, difference of two perfect squares. 25 is perfect, x squared is a perfect square, 9 is a perfect square. So difference of two perfect squares, right? So we're still going to follow our same process. My a is 25. Now if I don't have a b term, it doesn't mean b doesn't exist, it just means the b is a 0. And my c is a negative 9. Now, on a little side note, if I forced a b and I forced a trinomial, it would have to be a 0x, right? Because 0 times x is just 0. So that's why the b is 0. Okay, just a little side note. So we go through the same process. My b is 0. My a times c is negative 225. Now I need something that multiplies to make negative 225 and adds to make 0. So we need to multiply to negative 225 and I need to add to 0. Now the only way two numbers can add to 0 is if they're opposites, right? Negative 2 plus positive 2 is 0. Negative 10 plus positive 10 is 0. So I need a number times its opposite. Negative 225 is going to be a positive times a negative. But it has to be the same digits, right? So because I'm multiplying a perfect square by a perfect square, we can assume that 225 is also a perfect square, and it is. And what you get is you get negative 15 times positive 15. Okay, so the first thing again that you'll know is a perfect square times a perfect square usually creates a perfect square. And I'm pretty sure it always does. Okay, so my two numbers in my puzzle are negative 15 and positive 15. Those are the two terms that would add up to my 0x here. All right, so if we're working through, let's do the area model. My first term is 25x squared. My last term is negative 9. And then I'm going to have a negative 15x and a positive 15x. Now, a lot of different options it's going to possibly feel like. Here we can do 25x and 1x. We could do 5x and 5x. 25x and 1x is not going to work because it's going to have to multiply by something here to get 15. So that's really not going to happen. But I could do 5x and 5x. And you'll notice the square root of 25 is 5. Square root of x is x. Kind of worked out that way. Then to get negative 15x, I would have to multiply 5x times negative 3. And to get positive 15x, I would have to multiply by positive 3. And that works out. Negative 3 times 3 is negative 9. So we do end up with 5x minus 3. 5x plus 3. Now if we want to try the grouping method, we've got 25x squared minus 0x minus 9 is going to become 25x squared minus 15x plus 15x minus 9. And on a side note, it does not matter what order I do here. I could have said positive 15x minus 15x. It doesn't matter. So then we're going to group these together. We're going to divide out our common factors. Here I've got a 5x in common, and I'm left with 5x minus 3 plus, between these two, I've got a 3 in common. When I divide a 3 out, I get 5x minus 3. 5x minus 3, 5x minus 3. I'm going to divide that out. Oops. And multiply what's left. 5x plus 3. And if you notice, I got the same thing, both methods. There is something else I want you to notice, though, because this is a special pattern. Let's go back to our original expression here. 25x squared minus 9 resulted in 5x minus 3, 5x plus 3. 25x squared, 5x, 5x. Minus 9, negative 3, positive 3. There is a pattern here. Let's look at another one. $16x squared minus 4. Okay, both perfect squares, and it's a difference. So difference of perfect squares. A is 16, B is 0, C is negative 4. Add up to 0, and we need them to multiply to make negative 64. And remember, to add up to 0, we need to have opposites. Negative 64, if I have negative 8 times positive 8, that multiplies to 64, adds to negative 64, adds to 0. Remember, if I multiply two perfect squares, I get a perfect square. So I have negative 8, positive 8. Okay, area model, we'll just do it down below for space. I'm going to get 16x squared here, negative 4 here, negative 8x, and positive 8x. And then we've got to go through and figure out what goes on each side. You do have a bunch of different options for the 16x. And sometimes, you know, if you're feeling like you need to go through a bunch of different choices and it's a little overwhelming, you can start with this. This would either be negative 4, positive 1, positive 4, negative 1, positive 2, negative 2. You do have some options here. It can get a little bit confusing. Now, knowing the pattern from up here, because we're dealing with perfect squares, you'll notice that the square root is helpful. if you're ever trying to work the area model and you're struggling, grouping for the most part works pretty straightforward every time. But in this case, I'm going to use the pattern that we saw before, and I'm going to just kind of do square roots. And that's going to give me 4x on each side here. And 4x times -2, 4x times +2. And that gets me my -4 also. So we get 4x minus 2 times the quantity 4x plus 2. Again, the area model worked out nicely. Sometimes the area model doesn't. So let's practice the grouping one more time. So we're going to break down my middle term into the -8x and 8x. Break these up. And we're going to divide out our greatest common factor. So this would be 4x, and I'm left with a 4x minus 2. On this side, I can divide out my greatest common factor here would be a 4. The only problem with dividing out a 4 here is it's not going to leave me with what I need. So let me show you what I mean. This is going to leave me with 2x minus 1. Remember, my goal is to get a match for this. Okay, so a way to handle that, let me erase all this. The way to handle that, you might be saying like, well, I don't, it's a lot of options. I don't know what to do. If I factor out the GCF of my first set of terms here, then I know on this side I need a 4x minus 2. I know I need that. So I can kind of work backwards. I can say, okay, well, if I need a 4x minus 2, what did I have to divide out? Well, I divided out a 2. And that gets me my match here. Right? So then I've got a 4x minus 2 and a 4x minus 2 in common. Multiply by what's left. And what we notice, if we go back to our original, the square root of 16x squared is 4x. The square root of 4 is 2. Because they're being subtracted, I'm going to have minus 2 and plus 2. So you could, by rights, you could come to this factored answer without the area model and without the grouping model, if you've got a difference of perfect squares. Let's look at another example. What happens when we have a perfect square trinomial? It's very similar. Where we've got our leading term as a perfect square. Our middle term is not. And our constant is perfect. Okay, so instead of having no b, we have a b, but we've got a perfect square on each end here. Okay. Now, we're going to do the same process, identifying our a, our b, and our c. We add up to 40, and we're going to multiply to make AC, which is 400. So we need to find two factors that multiply to make 400 that add up to 40. Now, because we're dealing with perfect squares at the beginning of the end, remember, if I multiply perfect squares, I get a perfect square. And that's what we did. We multiplied two perfect squares together, so I'm going to end up with a perfect square. The square root of 400 is 20. So 20 times 20 is 400. 20 plus 20 is 40. So I get 20 and 20, which means 40x breaks down to 20x plus 20x. So now if we complete the area model, we have 16x squared and 25, and I get 20x, 20x. Now, we do have perfect squares here, and there are a lot of different options that you could start out with. But because these are perfect squares, I'm guessing that there's probably going to be some nice pattern, kind of like the last part where we could just square root. So I'm just going to try that out. I'm just going to try 4x and 4x because the square root of 16 is 4. And for 25, I'm just going to square root that and do a 5 and a 5. And if I look at the math, 4x times 5 is 20. 4x times 5 is 20. So what we get is 4x plus 5 times 4x plus 5. Or 4x plus 5 squared. Right? Any number times itself is squared. And if we look, square root of 16x squared is 4x. Square root of 25 is 5. And everything is added because we have a positive 25. Now, if we do the grouping model, I would get 16x squared plus 40x plus 25. 16x squared plus 20x plus 20x plus 25. Group those together and divide out. We'll divide out our greatest common factor here, which would be 4x. And I'd be left with 4x plus 5. So that means on this second part, I need to have a 4x plus 5 left, which means I have to divide out a 5. 4x plus 5 in common, pull that out, and multiply by what is left, 4x plus 5, which is also 4x plus 5 squared, which is the same thing I got right here. Now, again, these are special cases. You can work them out with the area models or the grouping model. If you tend to pick up on patterns and be able to remember patterns, you will notice that there is a way to come to the answer without all of this work. I'm not going to do it that way because I think the minute you start trying to jam rules in your head is the minute that everything starts getting jumbled. But do know that there are patterns, and if you can remember the patterns, you are more than welcome to go straight to your final factored answers. Okay, let's look at one more. But this last example, we're actually going to have a number that we can factor out from the beginning. So 12x squared minus 36x plus 27. So remember, please be on the lookout for a common factor from the beginning. And if we look, each of these numbers has a 3 that it can be factored out. And what happens is when I factor that 3 out, I actually have a perfect square trinomial. Perfect square up front, perfect square at the back. Now, if you recognized the pattern from the last example, you would know that our final answer should end up being 3 times the quantity 2x minus 3 squared. Square root of 4x squared, square root of 9 is 3. Because this is a negative number, I'm guessing it's going to be a negative inside. So that's my prediction. I'm going to predict that that's our answer. We'll see if that's what it ends up being. Okay, so that's my prediction. So we're going to go through and we're going to do our normal process, right? My A is 4, my B is negative 12, and my C is 9. 4 times 9 is 36. Now, because I'm multiplying perfect squares, I get a perfect square. Because I've got, perfect square at the beginning and the end, I know if I kind of square root the AC, it might help me come up with the factors that I need. Because if you see 6 times negative 6 does add up to, it does, negative 6 times negative 6 multiplies to positive 36 and adds to negative 12. Okay, so this negative 12x is going to become negative 6x minus 6x, right? So in my area model, I get 4x squared here and 9 there. Negative 6x in each of these boxes. And because I have perfect squares here, I'm going to guess that I will square root each on each side. However, always double check. Okay, don't just count on like, oh yeah, this is just going to be square roots. Because if we look here, 2x times 3 is not negative 6x. 2x times 3 is not negative 6x. I need these both to be negative. Negative 3 times negative 3 is still positive 9, but it also gets me my negative 6x's here, so you've got to be very careful. So what I get from my area model, don't forget the 3 that we divided out from the beginning. Do not forget that. Okay. 2x minus 3, 2x minus 3, which becomes 3 times 2x minus 3 squared. Okay, let's do the work with the grouping method. Three times 4x squared minus 12x plus 9 becomes 3 times 4x squared minus 6x plus 9. Let's group these two together. I'm going to do the additive inverse here, just so that I don't have that negative sign mess me up. And we're going to get 3 times, let's divide out a GCF here, 2x, and I'll be left with 2x minus 3 plus, now remember I need to have a 2x minus 3 left over. So in order to get a 2x minus 3, I have to divide out a negative 3. So my final answer is the 3 I have outside here. 2x minus 3. Divide that out and multiply by what's left, which becomes 3 times 2x minus 3 squared. Okay. And again, like I said, there is a pattern. I was able to get my answer from that pattern. It's up to you if You see it and you want to go straight to that, or you can use your area model or the grouping model. And that's it.